Hello and good morning, everybody. Here on the East Coast, if you're on the West Coast, it's really early morning, and if you're somewhere else in the world, it'll be afternoon. If anybody watching from Japan, thank you very much. It's really late. I appreciate it. Almost midnight there, or just after midnight. So we're here today to launch Avia 7. My name is Luciano Lucas. I'm the EVP, so the Vice President at DRVISION, and we are today at Wakeforest Downtown in North Carolina. And we are here with Glen and Heather. They are the facility directors here at Wakeforest Microscopy Facility. And we will be discussing what's new with Avia 7. We've been developing it since November when we launched Avia 6, and I'll get right onto it. Introducing Avia 7 today, and the main features are to do with tracking objects, tracking particles. It's our first version that includes 3D tracking. So I'm really excited to present you that. It's of course a huge team effort, and I'd like to thank everybody in Seattle right now. They've been working non-stop to get this release out, and we are all very excited and very happy that we have reached this landmark with this very exciting new version. So we have been active for last year. Actually, DRVISION has been around for 18 years, and it has a lot of expertise in machine learning. But the Avia tool that we are talking about today was really officially launched just April 2017. And you will see how much we have developed it since. So just a little bit before that, under still the name of SV Cell, we launched the first 3D neuron analysis. Soon after that, we integrated VR display. And with Avia 5, which was the first official release of Avia, we added a machine learning classifier for neurons primarily, together with 3 pre-trained models, and a very fast new algorithm for 3D neuron analysis. With 5.1, we added the spine support, so we could detect also spines and do a lot of neuron editing. So that was 5.1. And the machine learning classifier actually expanded and became more versatile with the types of objects that it could classify. Avia 6 was a huge new version for us because it introduced not only the very first and still the only deep learning powered software for image analysis, and we deployed it for the analysis of 3D EM data, detecting neurons essentially using just standard 3D EM data sets, non-labeled, and a brand new rendering engine for volume rendering, which I'll mention a little bit in a moment as well. Today, it's the launch of Avia 7, and we continue to push ahead with brand new and very exciting functionality. Not only the tracking, but also some new technology for surfaces, which are really essential in order to do the tracking efficiently. And we have actually quite a few other features that I'll also describe in some detail. So Avia 7 consists of these features. First of all, fast surface rendering, and this is essential for a lot of image analysis tasks. Then 3D tracking is one of those image analysis tasks that relies on good surface rendering, because you're typically looking at lots and lots of objects, and to do that efficiently you need a good way to render them. We have brand new track display options, which make it a lot easier to interpret the results. And because we know algorithms aren't perfect, we have a track editor in case you need to correct any of the tracks that are incorrectly assigned. We have continued to work on our aivia.tiff file format, and that was really the backbone of the version 6, which has the new volume rendering. And we continue to work on that to make it faster and make the files even smaller. so that it's easier to handle. And we added support for a few more file readers that are very common in the light sheet community. So first of all, fast surface rendering. So the fast surface rendering comes on the heels of the story we started with Avia 6, which was fast volume rendering. And volume rendering is really the first type of data rendering that people typically use after acquiring the images. And it is good for visualizing results, not ideal for looking at or visualizing raw data, not ideal for looking at segmented data and actual results. So back with Avia 6, what we introduced, just as a reminder, was a multi-resolution, multi-block architecture for the file, which makes it behave a little bit like Google Earth. You can zoom in and zoom out and really handle extremely large data sets, so multi-terabyte data sets on regular computer. And it does that by quickly swapping in and out the information that is required at each zoom level when you're panning and moving around your data set. That in itself was already very good, but the best part was actually the algorithm for determining what that architecture should be. And we have, I believe, the only one that is dynamic. So it uses all the information that it can gather, so all the hardware information and also the information about the image. And depending on a number of factors like image size, GPU, type, and availability of memory, it will calculate what the shape and the number of blocks is. So that makes it really unique and a lot faster than other solutions out there. So that's the volume rendering reminder. But if you're doing image analysis of large images, volume rendering is only so good. It will let you look at the data, but it won't really help with the analysis side of things. So volume rendering, the standard volume rendering comes typically with this kind of color, so black to white, and each pixel that you acquire, so creating optical sections with your microscope, each pixel will have an XYZ position and an intensity. And if you take those pixels and you know what the depth of each pixel is, you have then a number of voxels, and because you have their 3D coordinates, you can plot them in 3D and give them the right intensity value. And that's what A is. So this is using the standard lookup table, or LUT. You can pseudo-color it if you like to play around with colors, or you have something of interest that you want to highlight. And this is an example down here. That's a zoom-in area roughly around this region of the pseudo-colored volume rendered dataset. And down here, I start to show you a little bit about the surface rendering. So the surfaces are, I think, visible there for you, and they look like a little bit like a mesh, and they are representing already the segmentation result that I ran using Avia. So those little meshes that we see there are a simplification or representation of the volume of the object. And these little meshes are what's this part of this presentation all about. Then these meshes, if we look at them carefully, they're made of little triangles. If you fill in all of those faces of the triangles, you can see them as solid surfaces, as they look like here, like a little bit like jelly beans. And these, if you peel them away and zoom in, they look like the image you see on the bottom. So how do you get to this kind of representation of data? So imagine you take an optical slice through one of those objects, through one of these cells. Take an optical slice, it's going to look a little bit like that. So the pixels will have an intensity something like this. So in the center they're bright, around the outside they're a little bit dimmer, and towards the edge they are even dimmer, and then it goes into background. So that is what an optical section would look like for that kind of image. Just turning on my video again so you can see me. Okay, so that's what it would look like if it's an optical section through a cell like this. When we then want to segment this region, we set thresholds typically. That's how things are typically done. You set a threshold. In this case, I set a threshold of 70, so somewhere between 50 and 80, there'll be an ISO line or a boundary created. And that's for one optical section. If we then look at multiple optical sections, so I'm going up in Z or down in Z, either way, what happens is the intensities will drop away, of course, because you're moving up this way or down this way, so less voxels will have the bright intensity because it's a smaller cross-section. And if you build a 3D block, it will look something like this. That little corner that we saw in the previous picture actually looks a little bit like that. And if you have, if you can imagine the other 7 cubes, this is one of the cubes. If you imagine the other 7 cubes, it will actually make a 3D shape that looks a little bit like that if you threshold it around these light or dark gray, voxels. So why do people like to do surface rendering in the first place? First of all, it's the easiest, most direct way to get to morphometric information. So the length of an object or the volume of an object is easily calculated or quickly calculated if you already have the segmentation done. Also, it's ideal to check the segmentation results because you can turn things on and off, turn the surface on and off, and keep the volume rendered version there. So it's very easy to check if your segmentation took place correctly. And because it's an independent entity to the volume rendering, you can color each one of them separately. Again, for display purposes and for exploration of the results, this is really useful. From a technical point of view, one of the key reasons is that it has lower memory requirements. And that's also one of the reasons that the movie industry and the gaming industry uses surfaces rather than volumes for all of their games and videos, because it's a lot easier to render and render in lots of triangles, so lots of detail. And it is definitely easier to interpret because it's a binary. It's just a sheet, and what's inside is part of the cell, what's outside is not part of the cell. So you've made your decision where the threshold is, and it's then much, much easier to interpret. So this is why people like to use surface rendering from a technical point of view and from an application point of view. Now, there are challenges in making this fast enough. We have now tackled that is significant bottleneck by optimizing quite a few of the steps along the data pipeline. So this is the data pipeline in aivia 7. We start out with the data, of course, in the storage device, whatever that is. In my case, I try to always use SSD drives because they give me the best performance, and I suggest that you do the same. And so we first of all load the data or load the needed meshes from storage onto RAM. And that's a very fast process if you have SSD. And then after that, once the meshes are there, we generate the meshes in real time. And once the meshes are generated, so the meshes would be all the cells, the tracks, and so on. We then intelligently cache those meshes, and that's actually primarily the cells. After that, we feed those meshes that were already cached. Some of them were already cached if we think it's the appropriate thing to do. Depends on the circumstances, but in many cases we cache them. We then feed those to the mesh display manager, also known as the mesh data manager. Once it's in here, and this is perhaps the most critical step in our pipeline, once it's in here, it actually is the place where we will package and organize the meshes in such a way that the GPU can process them most efficiently. And we've implemented this on a dedicated thread, which means it doesn't compete with any other operation that aivia is performing. So it ensures that it has basically right of way using the CPU when it's doing this. And this is the most expensive part of the process. So by optimizing this step and giving it priority, we've sped up the mesh rendering mesh display and rendering extremely, and you'll see the numbers in a few moments. After that, we upload those nicely packaged and organized meshes onto the GPU and let the GPU do its magic. GPUs are already highly optimized for this type of work. Then they will stream the information to a screen, flat screen, like on a laptop, or to a VR headset, which we also support, so that you can do that from Avia, either of them. So in essence, this is what we're doing to optimize the process. We are multi-threading the rendering, we're optimizing the GPU packaging and loading, and we are intelligently caching the surfaces that we're generating. And this goes for all of the surface components, both the objects, so the cells themselves, as well as all the track display options that you will see in a moment. So what does that actually look like? So on the left is Avia 6, and actually many other softwares in this space do it in the same way. So Avia 6 does it like this, and the time is passing, going up here and going here. And you can see that it's taking quite some time for the video on the left to advance in time. I pressed play, and it's still on the third time point or fourth time point there, whereas the one on the left-hand side has already passed all the time points, and actually I'm interacting with it. I'll start that from the beginning so you can have a look. So this is at the beginning, this is at the beginning. I press play on the video on the left, press play on the video on the right also, and instantaneously you see the video on the right is loading pretty much real time and just going, you can see the little time bar going up there. I rotated the videos so that they fit nicely on the screen like this. And you can see I can, not only it's loading a lot faster, but I can interact with it. I can rotate it, I can zoom in, I can zoom out, I can even change the color on the fly, color code the objects by any measurement that I like. That's what I do in the last part of that movie. So the experience is has extremely improved from Avia 6 to Avia 7. And what Avia 6 did is pretty much what many other tools do out there. So we've invested here in creating an experience that I think is one of the best, if not the best, for looking at surfaces over time. So what that looks like in terms of numbers. So the standard or the Avia 6 rendering mode would take, for a data set like this, it would take around 300 seconds to pass through all the time points. Whereas with Avia 7, it will take 12 seconds to get to the same time point. So it's 50 time points, 24 gigabytes data set, and we are rendering per time point around 5,000 cells and around 730,000 triangles per time point. So you can roughly guess how many triangles it takes to make a cell, to make a surface rendered cell. So that is an enormous difference, and it's not only the time it takes, but it's also the fact that you can continue to interact with the scene while it's loading. Should be, and it is, a big improvement, and I hope you will enjoy using Avia 7. So summary of the key numbers, it's actually 12 times faster versus version 6, the rendering of the first time point. If you look at rendering of all the time ports, the first playback, so this is while we are rendering, generating, and caching, it's 13 times faster, that first playthrough. After it's cached, it's then 28 times faster because we didn't cache almost anything for Avia 6 and other versions before. And we did quite a bit of testing with many data sets, and this is an example just for you to get a sense of how long things take. So for the 5,000 cells, it's nearly instantaneous. It's like a second. If you have 150,000 objects in one scene, in one time point, then it takes about 6 seconds for the first playthrough, so the first load and render. Of course, when you play back, it's nearly instantaneous. It doesn't stop because it has cached everything. And the same data set with the same number of objects in other tools and in Avia 6, so the old version, it would take 83 seconds. So that's it in terms of volume rendering and surface rendering, the fast surfaces. That's what I had to mention. We also have introduced a new algorithm for 3D tracking. So now the algorithm itself is a very robust one. We've used the 3D object detection partition steps that we had previously that were already very nicely tested and were working well. And we've added tracking to those cells or to those to that object detection. And the tracking has two parts to it, or two scores. The first part is to do with the motion. So it analyzes the motion of a particular object and it gives it a score. If the object is typically going in the same direction, so in a straight line almost, then it will have extremely high score. So very high likelihood that it's the same object moving in that direction. Of course, if it's Brownian motion, then it will have a very low score and that wouldn't work if we had just that one parameter to optimize the tracking. But we have a second one, which is morphology. The morphology is a merge of a factor between intensity and volume. And so if an object is changing its direction a lot, but keeps its intensity and or volume while it's changing its directionality, we can still track it. And the user gets this slider here, and you can weigh your preference. So if you see that your objects are behaving in a more Brownian motion kind of way, you slide this to the left, to the right, and you are essentially almost ignoring the motion part of it. You're using primarily the intensity and the volume, so the morphology score. If, on the other hand, your objects are changing morphology significantly, but their motion is consistent, so it continues the same in different time points, then you can adjust this to the left, and motion will be weighted highly. If it's somewhere in between, you can just leave it in the middle, and it will work just fine. Once we have those two scores, we then use Hungarian or greedy algorithm to decide to assign the objects in a time point 2 to time point 1 and connect the different time points. And finally, there is a post-processing step for removing tracks that are likely to be wrong. So if they're very short, for example, they're likely to be wrong, and the user can define a minimum track length so that those are removed from the final result. Or you can keep them and then use them for editing, for example, if you set this to 0 here. So that's the algorithm we have. And I should say, if you have an algorithm that you really like and it's different from this, it is not a complicated task for us to implement the algorithm that you would like to have. And we can just add a new recipe that would have a new algorithm or a different algorithm that maybe your lab developed and you would like to see it deployed in Avia, so you can use it in your lab together with all the other Avia tools. So let us know if that's the case. We are open to that kind of collaboration. So motion score, if we visualize it, I thought this was an interesting visualization to give you an idea of what it looks like. If you visualize the motion score with a confidence map. So if what it says here is very little VP equals 0, VP and VP. So this is to do with the velocity. And the motion is all about velocity and directionality. So the motion score takes into account these 4 parameters. And if an object is not moving much between time points, what happens is the velocity, almost all of those will be 0. And so the search range that we have is really what controls our confidence. We look within a certain range around the cell from time point 1 in time point 2. And if the cell is there, then we connect it up. And so our confidence is high if it's very near, and it's low if it's further away, of course, because the cells don't tend to move much out of the range that the user specifies. So this allows us to display or shows here a confidence map for that score, how that score would look like. So if an object is moving a fair amount forward and we have a vector that shows that directionality, then our confidence map for the motion score would look like this. It starts to look a little bit like a flashlight. So still brightest is, of course, in the center, and then you have these areas that extend out that are of lower confidence, but we can still connect objects that are out here. And if the object is moving really fast, then you have something extreme like that, where you will try to connect to objects that could be very far away from the object that you were looking at in the previous time point. The track display options have also been worked on significantly. And this comes because we've worked so hard on the surface rendering. We can benefit from using this track display or reusing all the pipeline that we created for surfaces. We can reuse it for track display. And this is where you will find it. It's right here. The track display options are in this section of Avia. And you have quite a few of them. And we can provide lots of them because they're all very fast. So we can afford to have all of them visible to you. So what are they? The first one is, or I'll go around, you can turn on and off the objects, so the actual meshes that represent the cells. You can turn on and off the tracks themselves. The anchors, these are the center points for each of the objects that we detected. And you can turn on and off the trends. This is a vector between a time point and another time point. And you can actually control which time points you're creating a vector for. The track length, that's obvious, and the radius, which can be controlled for each one of the objects here. You can make them thicker, thinner. That's what the radius is for over there. You can also color code all of these objects independently, and you have all the ones that you used to have, and now we have also the color by measurement, and it will feed, it will take information from the spreadsheet. So any measurement that we have there, we can use to color code. And a very important one for us, color by class. This is to color objects that have been classified using our machine learning classifier that is part of the standard Avia. The meshes themselves can be rendered solid surfaces, wireframe, or points. And the anchors, you can have all of them visible for the current number of track points that you're displaying, or just the current one, so that shows us the one in front. For the trends, you can have the full track, first to current, or just the ones that are currently visible. So you have all of those options, and we think that this covers pretty much everything that you might want to do in terms of track display. So here's a summary and some examples of how this looks. I'll just turn my video off for a moment so you can see the table. So you can see the summary here. You can turn on and off all of them. The length, you can control all of them, apart from objects, of course. You can't change the length of the object. That's the fixed size. Also, the size and thickness you can't change for objects, but you can change for all the others. And the color you can change for all of them. Okay, the track editor. The track editor has, this is a brand new part of Avia as well. We redid this from scratch, and it includes these 4 concepts that I'll go through. The first one is you have a workspaces concept. You have a space where all your tracks, if they're lineages, all your lineages are visible. And then you can create these custom workspaces, and each one of them behaves independently from the others. You can select some tracks over here and add them to a workspace. And if you do that, your view will be decluttered in the editing window over here. But also, and importantly, you can choose to hide all the other objects in the 3D view. So if you have a very busy scene, you can just work very focused on a particular group of tracks. And that's much more comfortable than looking at all of them. There's a few other very nice things about the workspace's concept, and I'll show you that in the demo in a moment. Pretty much every interaction is drag and drop. You can do most of the editing without using keyboard too much or buttons. So that's very comfortable. It makes it for a quick editing and a good experience. And there are multiple selection modes. You can select tracks in the 3D view, you can select them in here from the spreadsheet. There's also some quick ways to put tracks into particular workspaces and move them around. So there's lots of options. One that I really like is the track sorting. You can sort them by a measurement. So put the ones at the top that have lots of branches, so a lineage that has lots of cell divisions. You can put them towards the top, and then in a descending fashion all the way to the ones that have no cell division at all. So that makes it a lot easier if you're trying to find the tracks that you want to edit. You can also sort by selection. So if I click on 2 or 3 of these, they will go to the top. And again, that will help with the editing process significantly. So that's what it looks like. Little video with the selection. So I'm selecting there some tracks, and I'm moving them to a new workspace. You'll see there's a new workspace now visible. And the editing is very straightforward. So you just can click, drag, and drop. And if there is a question about what could happen, it will pop up, and you just click again to choose what you want to do. Typically, there's 2 questions, 3 options, which is lineage. Do you want to create a lineage? Do you want to merge, or do you want to disconnect a track at a particular point? And there are ways to disconnect directly. If you want to disconnect, you just click on a point and move down out into an area where there's nothing, and it will disconnect that track. But as you can see, it's extremely straightforward to create a lineage if a lineage is not created, or to make any sort of edit, actually. I wanted to mention the faster and smaller aivia.tiff file and what that actually means. So we did a number of tests with a number of data sets, and these are the averages for the summary for those results. So A6 means Avia 6, A7 means Avia 7. So we are launching today the 7 version. And you can see here rendering itself, on average, it was taking 80 seconds. It's now taking less than 10 seconds. It's something like 7 seconds. So that's the speed at which the speed improvement. You can see it's very, very significant there, just for the rendering. For the selection, it's even more drastic. So this is clicking on a cell and seeing that it becomes selected. It used to take over 20 seconds, sometime on average, for these examples, because some of them are extremely large meshes, and so those take a long time to select. Did take a long time in Avia 6. In Avia 7, all of the interactions are instantaneous. They happen within 1 second or even less. Actually, it's a lot less than a second. The first playback used to take a long time, so 70 seconds. It's now taking less than 10 seconds, or around 10 seconds to the first playback. And for the second playback, so after caching, it went down a little bit from within 6 from the first time to the second time. But if you compare to Avia 7, the drop is drastic. It goes from around 65 to all the way down to about 10 seconds, or even less. I think it looks like 6 or 7 seconds. So right now, any data set pretty much that we want to render, and this is volume rendering, I should say, that I'm talking about here. Any data set that we want to load and render in Avia using the aivia.tiff file format loads within 5 seconds. And that goes for any size. It doesn't matter what the size is. If you want to know more details about why that is and how that happens, we have a YouTube recording of the launch of Avia 6. Scroll roughly halfway to the middle, and there is a chunk of, presented by me and Sean about how our volume rendering works and how we can get down to these nearly insane levels of performance. So this is a summary for this portion, the faster and smaller aivia.tiff. It's nearly 2 times faster to do the offline conversion, so it cuts the time it used to take by half. And we can do this with a batch process. We have a batch processor for offline conversion of files. So we take in TIFFs, for example, regular TIFFs, and we convert them to aivia.tiff 2 times faster. It used to be around 5 gigabytes per minute, the conversion. So I would expect now it's something like 8 gigabytes per minute for the conversion. It's also 1.7 times faster to do the full-time series volume rendering. So we've improved the caching. That's why that is faster. And it's 1.4 times faster to do the first interactive rendering. So from file open to seeing something. But anyway, it was already nearly instantaneous. It was 3 or 4 seconds, sometimes 5 seconds. Now, on average, it's never more than 5, and it's typically 1 or 2 seconds to load the data set. The file, even though we did all of this, the file is actually smaller, 1.3 times smaller than the 6.0 version of the same file. And the online conversion, so the on-the-fly conversion from flat file to multi-res, multi-block is also faster. So if you load something that you've never used, never put into Avia, it will actually fill faster than it did with 6, which was already pretty fast. And finally, we have added support for a number of file formats, a lot of them in the light sheet space. The first one, the SLD from 3i, triple I. And the next one is not light sheet, but it's a laser-free confocal microscope from Aurochs. They have a particular OME-TIFF plus companion file that we added support for. Then the next one is from Luxendo Bruker, the H5. This is a HDF5 derivative. So we have now support for HDF5 derivatives, so we can read the multi-res, multi-block information in the H5 and in the IMS, which is the IMARIS file format. This means we can get pretty good performance out of the box when we load number 3 or number 4, because we are using the multi-res, multi-block information that is in those files already. So there is some work that needs to go into creating those files. We are now using that that information to get fast rendering. So this will be a lot faster than loading a TIFF file. However, it's still even faster to just convert to the aivia.tiff. And that will be still the best performance. The ultimate performance in Avia will be with aivia.tiff. But you can get pretty good performance just because we've now added support for the HDF5 file format. And I should say the aivia.tiff opens in other tools because it includes a full res flat file of the original data. So we have the multi-res, multi-block plus a flat version that any software will pick up. We made sure that it's easy to find when you try to open the file. All the other softwares will be able to open it as a regular TIFF. So we're getting to the end. This is pretty much my last slide. This is all the functionality that we now cover in aivia.tiff, in Avia 7. We do the visualization, as I already mentioned, with volume rendering and surface rendering. We have full integration with virtual reality, so you can render things directly on a headset. We do a very large number of 2D applications. I think we have 15 different recipes for 2D cell analysis, and some of them are also with time. We do 3D object analysis, which was launched with Avia 6, and we've made actually pretty big improvements on the partitioning in Z. We've improved it a lot. The 3D neuron analysis has received some love too. We changed the algorithm, tweaked it a little bit so that it's better at recognizing the right branching patterns in complex locations. And the machine learning is still there, and it's a key part of Avia. In fact, you've probably seen it says artificial intelligence just behind me. So pretty much everything you do in Avia can
then be fed through image analysis, machine learning pipeline for classification, exploration, and discovery of different phenotypes. And that's the machine learning classifier that we have right here. So you teach by example, and then the software can recognize phenotypes, cell phenotypes, or go and look for phenotypes that you have not taught on. We also have 3D EM image segmentation using deep learning. I mentioned that at the beginning. That's still the only, at first and only, that does that. And now we have 3D tracking, which we actually featured at ASCB EMBO. We had a poster and presented it there, which was a lot of fun, a lot of good feedback. And we've optimized the performance and the GUI drastically, especially for surface rendering in this particular version for Avia 7. So I'd like to thank the team that has worked on this, and they are really the stars for Avia. They've worked tirelessly for the last 3 months to create this new, brand new set of features and functions. And really, I'm very, very impressed with the teamwork that I've seen over the last few months. So thank you very much, and congratulations, guys. You did a great job, and I'm sure people will appreciate the effort that you've put in. So Avia 7, this is what it includes. I will now proceed to do a brief live demo of the key features, and then we'll conclude. So I'll do a live demo of the fast surface rendering, 3D tracking, track display settings, and the track editor. So give me a moment to change my view here, and I'll start the demonstration for you. So that's what the original data looks like. Okay, so you can see me as well. So that's the original data. I'm going to play it through very briefly so you get the sense of what it looks like. So this is the first time I played through this data set in volume rendering. That's why you see actually the blocks loading. You can, of course, go to any of the time points and instantaneously you get that, and we are buffering or caching those. So after it runs through a particular section, it's now going to fly through those time points, like this section here. And if it hasn't loaded that part, then it's going to take a few moments. So this is what Avia looks like. I don't know if you have never seen it. There is a very large window where your data is displayed. There's a collapsible panel on the bottom that has lots of goodies like the spreadsheet, some editing tools, and also the image explorer if you have multiple images open. And then on the right-hand panel, you have the lookup table controls, so display controls over here, which you can zoom into like this to see a different part of the curve. You can also control the display settings for the tracks. That's something I'll show you in a moment. And then at the bottom you have the place where you can start and run all of the recipes. You can see these are all of the pipelines that we have created for you. These are all preloaded, including the deep learning one is right here, 3D EM. So the 3D object tracking is here. We can expand it. We see all the steps, which is very convenient. You can edit each one of them independently and get a preview straight away. Excuse me. Which is a very convenient way to set up the analysis pipeline. Okay, so that's the raw data. I've already done the analysis so that we don't have to spend time here, and I know that you want to try it anyway on your own data in your own time. And so what I'll show you here are the results. So this is the data. I'll turn on the objects, and you should be able to see them now. Okay, so this is the representation of those objects. You can see the segmentation is pretty accurate. I'd say nearly flawless for this data set. And we can show then this playing through time. As I showed earlier, it takes less than a second to progress between time points.
but then it gets faster as it caches. Currently, all these objects are colored in a single color. I can color them any way I want. I'll get there in a moment. So going through the display options. These are the meshes. You can turn this off and on. You can also have tracks, which you can control the length of. So if I play like this, you'll see the tracks of all of these. You can control their length over here, make them longer, shorter, as you wish. Then the anchors are, in this case, I'm displaying just the last time point, or the current time point. So it shows the point in front, and I'm color coding for something. I'll get there in a moment. And then you can also have trends. And I'll turn off the tracks for a moment so you can see the trends a little bit better. So the trends are also color coded, and in this case, I'm just showing a partial version of those trends. These are they look like little vectors. That's in fact what they are. I can make them a little bigger for you. And this it's really useful when you have complex situations where looking just at arrows simplifies the view and gives you an overall sense of the data set. And you can see when I adjust something, it takes a little bit to buffer that particular version, but after that particular display setting, but after that it runs seamlessly and extremely fast for all this. And you can have all of this on, of course. The surfaces are the more expensive ones to render, so they take a little bit longer. But typically, you can do you can choose a setting that is comfortable for you. So that is it in terms of options on this side. Now, on this side, you can color code objects by a particular setting here. So you have solid color, which means you can just pick any color you like this, and you can see that it's nearly instantaneous, the change in color. You can choose all of those, and the color by measurement is a new one. I'm just going to color it by Z position, so you can see that it's colored by Z position. You can color code it by anything else you like, really, any measurement that we have. And you can do the same thing to the tracks. I zoom in a little bit and make them a little bit more chunky. Okay, so they're a little bit more chunky, and I can make them also longer. So they are the tracks. And the tracks are currently color-coded for Z, actually. I'll just do straight line velocity and adjust here the color that I'm interested in. Okay, so they have pretty similar straight line velocity, so that doesn't help much. I'll pick here the total intensity of the object. So we're taking a measurement from the surface and mapping it onto the track. And this looks at total intensity. And you can see you can color code that. And you can also color code the tracks, these arrows, so the trends. You can change the color mapping here, and you can change the parameter that you're using over here. And that's it. So these are essentially all the options. You do have a few more that I didn't go through, but for the sake of time, and I'm sure you want to try this anyway on your own, I keep it there. So that's in terms of track display and tracking in 3D. So where is the track editor? So the track editor is right at the bottom here. It's one of the tabs on the bottom panel. And if we click on it, it opens it right here. By the way, the spreadsheet is next to it with all the data. And all the views are actually connected up. This view connected with synchronized with the track editor and actually with the charts, which I'll show you in a moment. And you can zoom in. Very nice shortcut is the Z. It zooms into a particular track. And also a very nice feature, that's a new feature too, is the possibility to follow a particular object. And that's a really good tool when you're editing. So let's say you're selected, I selected that particular object, let's say selected this one. I'm actually going to sort this by selection. So the selected track goes to the top. And there is a tool here which says follow 3D track. If I turn that on, I actually can't see if I did turn it on or not because it's very dim here. And I play through, let's see if I can do that. It's actually going to follow that track, adjust the view as I follow the track. So you should never get to a position where your track is out of the view. I think I can't see if the button is on or off, so it might be off. So I'll show you that in a moment. So the track editor is down here, and it is also color-coded. It can be color-coded. It's color-coded by the track colors that you have here. So if I change this to any of these other measurements, it will update the color coding here. So a particularly good one is color coding by intensity or color coding by number of generations, which helps with the editing. So the editing itself, there's a few pipelines that we found people have. Either they do it regionally, so they would go in and say, okay, I want to edit these objects that are in this area here. So I want to do these guys, maybe all of those. So you want to do those, and you want to move. Then if you do that, you change this to a different workspace. I now have these few tracks in the workspace 1, which I can call renamed work in progress. Did I type that right? Yeah, good. And I can also hide all the others. So in this mode, I just show the ones that are in this particular workspace. And I can now go in and do all my editing. By the way, this is zoomable also. The tracks here are zoomable. You can pan. And the editing is really straightforward. Okay, so selecting that one track. And let's say I want to connect this one to this one. It asks me, do you want to create a lineage or merge? I want to create a lineage, so it creates that lineage, and it's that one there. I can go look at it. I can also break it apart. So if I go back in time over here, I'm going to make the tracks a little longer so we can see all of them there. And to break it apart is very straightforward. Just drop it below, and it will, you saw there, it just breaks it apart. To connect it up, you connect it up just like that. So that's the full track. It's also useful sometimes to have the tracks color-coded by ID or by name, because then you see where the breaks exist. So that's track right there, and it changes at that point in time. It changes color because that's where the branching is taking place. So if I edit this particular track here, right there, if I wanted to break that track in two, I would do this. And now I have those two tracks. There, two colors. So those are now broken. If I want to connect them up again, I can select them and just connect them up again. And now they will have a single color, because they are now part of the same object. So that's a little bit of a crash course on track editing. You can do all the track editing down here. The visualization is updated on the fly. We have quite a few options to help you with that. So this is one of them is the hiding of the tracks that you're not currently editing. But all of these workspaces are connected up. So if you are back in the all objects view, you will see in all of the objects, including these work in progress ones. And you can have another one, you can have actually as many as you like. So let's call this finished or edited. And let's say you finish editing this one that has a lineage, and you say, okay, move this to the finished workspace. Or on the keyboard, you can just hit number 2, and it will take that there, because this is workspace number 2. This is all objects, so that's workspace 0. This is 1, 2, 3, 4, 5. So you have shortcuts on the keyboard to move tracks to different workspaces. Actually, it's not moving, it's mirroring. So they exist still on the other one. So this still exists here. If I want to remove it from here, I can, but it's by removing it. So I can delete it from here, and that would delete it from. Actually, I just deleted the whole track. The good thing is there is an undo, so I can just do Control Z, and it should bring me my track back, and there it is. Actually, the undo works for multiple steps, so you can keep undoing, and it will just undo until it goes back to the original state. Because it needs to calculate some measurements sometimes, it may take a little moment to undo everything, but it's all there, and you can continue to undo as much as you like. So final thing I wanted to show is the scatter plots. Together with the data that we have. So we have this, and you can plot any parameter of interest. I have a difficulty seeing actually. Let me see. Okay, maybe average intensity versus, yeah, so it doesn't show, it's too small, right? Yeah. So this may be too small for you as well, but what I wanted to show is that this is updating, it's connected up. So as the data is progressing here, it's updating in real time the plot on the right-hand side. And you can select things from the plot as well. So I just selected a few tracks, and it shows them selected in this view. They become white, and they are also selected in the track editor, as well as in the spreadsheet. So really you have nearly endless options to get to your data and to edit them and to export them. You can export everything from Excel here, and you can of course create pictures or images to export also here. And these plots are also color codable by a measurement. That's what I was doing just there. Okay, I think I might have covered everything I wanted to cover today for track editing. Actually, there's a few things I didn't cover, but you will find them on our website or in other materials. One of them is that you can actually create objects on the spot in case an object is missing. You can go in and create one. I might actually show that. So let's say if this object here wasn't there. So I just delete this one so that I have something to edit, because I think this data set is actually quite accurate. So here is an object that I want to detect. I go into the object creation tool, and I can click on it. You can see that it creates something on the spot. I just create an object, and now that object is editable. Or you can connect this object to an existing track. So if you have a track with a gap and you want to add an object there, you can go and click on it and just create it on the spot. So that's just one more option for the track editing solution. So to summarize, this is what we covered today. We introduced the fast surface rendering, which is a technological improvement that then opens up all sorts of possibilities for image analysis. And today I featured the 3D tracking, but actually the fast surface rendering is also very, very useful for any sort of image segmentation that relies on surfaces. Even if you have a single surface and that is made of enormous amount of triangles, then this will be of high benefit as well. So we covered the 3D tracking, the track display options, which are extensive, the track editor, which I briefly demonstrated. There's a lot more functionality there that help you edit tracks. The faster and smaller aivia.tiff, so that you can more quickly get to a high performance file format for volume rendering, and the support for additional file readers, which should make your life a lot easier. If you have any of those files, you don't need necessarily to convert them to aivia.tiff. You will have pretty good performance out of the box, especially for the IMS and H5, which have the HDF5 multi-res multi-block information in them. So with that, I would like to thank everybody that joined us today online and also here in Wake Forest. And in a particular big thanks to my team back in Seattle. I'll see you all on Monday, and I'm looking forward to celebrating a great Avia 7 version. Congratulations, everybody. Thank you.